Watch this. A thick piece of plastic, snapped clean in half. The kind of break that every repair shop, every appliance dealer, and every auto parts counter will tell you is a death sentence for your machine. Now watch what happens next. One single drop of clear liquid applied directly to the broken edge. Then, a tiny pinch of white powder, the kind sitting in your kitchen right now, sprinkled directly on top of that wet glue. There is a faint wisp of smoke, a tiny crackle of heat. And then, in 3 seconds, not 3 minutes, not 3 hours, 3 seconds, the joint is solid. Now, a pair of heavy steel pliers grabs that same piece of plastic and squeezes with full force. The plastic around the repair bends. The plastic next to the repair groans. But the bond itself, the actual joint where the break was, does not move, does not crack, does not give even a millimeter. The repair is not just fixed. It is, by every measurable definition, stronger than the original piece of plastic ever was. $2, 3 seconds. And a machine that every manufacturer in America told you was garbage is now back in your hands, fully operational, ready to run for another decade. You have never been taught this. And that is not an accident. Think about the last time a piece of plastic broke on something you owned. Maybe it was the tiny locking tab on your vacuum cleaner's dustbin. Maybe it was a refrigerator shelf bracket. Maybe it was a clip on your car's interior door panel, or a gear tooth inside a perfectly good appliance motor. The machine itself, the motor, the compressor, the engine was completely fine. One piece of plastic, smaller than your fingernail, failed. And suddenly you were staring at a choice that felt like it had only 2 options. Pay a repair technician hundreds of dollars to swap out an entire assembly because the manufacturer conveniently refuses to sell you just that one tiny component. Or throw the whole machine in the trash and buy a brand new one. That is not a coincidence. That is a business model. The $500 billion appliance and auto parts industry does not make its real money selling you one product that lasts 20 years. It makes its money on the second sale, and the third, and the fourth. Engineers at these companies, and there are internal documents that confirm this, are given specific design mandates. They are told to identify the highest stress points in a product's mechanical system. Then they are told to manufacture those exact points from the cheapest, most brittle plastic possible. They call it value engineering. The rest of us have a more accurate name for it. Planned obsolescence. They design the weak point. They manufacture the weak point. They sell you the machine, knowing the weak point will eventually fail. And then, when it does, they make it structurally impossible for you to buy just the broken piece. You have to buy the whole assembly. Sometimes you have to buy a whole new machine. Their entire revenue model is built on one foundational assumption, that you will never discover that you can rebuild structural plastic from scratch at home for $2 in under 60 seconds. Welcome to the buried blueprint. I'm glad you found this channel because everything we cover here is exactly this. Real, proven, documented knowledge that powerful industries have a direct financial incentive to make sure you never learn. If you are new here and you believe that the information you need to protect your home, your wallet, and your independence should not be locked behind corporate profit margins, then hit subscribe right now and tap the bell. Every single blueprint we release disappears from recommended feeds fast. The algorithm does not love this content, for obvious reasons. Subscribe so you never miss one. Now let's talk about what you actually just watched happen. Because what looks like a magic trick is actually one of the most straightforward and violent chemical reactions you can trigger at room temperature with 2 ingredients. Here is what is happening at the molecular level, explained simply. Standard superglue, which is a chemical called cyanoacrylate, normally cures by reacting with tiny traces of moisture in the air. That process is slow. It can take minutes or even hours to reach full strength. And because the curing happens from the outside surface inward, the final bond is often brittle and shallow, which is exactly why regular superglue snaps apart under stress. It is cured on the surface, but not truly hardened all the way through. Baking soda changes every single one of those variables simultaneously. Sodium bicarbonate is a powerful alkaline compound. When cyanoacrylate makes contact with it, it does not wait for moisture from the air. It detonates. The alkalinity of the baking soda acts as a massive, instantaneous chemical accelerator, triggering what chemists call exothermic polymerization. That means the molecules in the glue start cross-linking at an explosive rate, and they generate heat as they do it. That little wisp of smoke you saw is real. The joint is genuinely getting hot in the moment of curing, but the result of that violent, rapid cross-linking is a fundamentally different material than what regular superglue produces. Instead of a brittle surface-cured film, you get a dense, 3-dimensional acrylic polymer matrix. A rock-hard structural cement that that has physically bonded into every microscopic pore and crack in the plastic surfaces it contacted. It is not just gluing the surfaces together. It is becoming part of the material itself. And here is the part that the specialty adhesive industry, with its $25 epoxy kits and its $40 structural bonding compounds, desperately wants you to overlook. This reaction was not discovered last year. Long before any of those products existed, this exact chemical combination was already a known, trusted, field-proven technique used by professionals working in some of the most demanding environments imaginable. Aerospace maintenance technicians used cyanoacrylate and accelerant powder combinations to make rapid structural repairs on non-critical plastic components in aircraft during situations where slow-curing epoxy was simply not an endire's option. Guitar luthiers, who work with some of the most structurally demanding wooden and composite joints in any craft, have used this reaction for decades to rebuild broken headstocks and repair cracked bodies with bonds they trust to survive the constant tension of steel strings. Professional scale model makers and prop fabricators used it to sculpt and rebuild plastic geometries from nothing, layering the glue and powder to recreate shapes that the original manufacturer never provided replacement parts for. These are not hobbyists experimenting in a garage. These are professionals in high-stakes fields who adopted this technique because it worked, because it was fast, and because nothing they could buy at any price performed as reliably for rapid plastic reconstruction. This knowledge has been sitting in professional circles for over 50 years. And the reason you are only hearing about it now, the reason it never made it into a mainstream home repair guide, into a hardware store brochure, or into a single piece of official advice from any appliance manufacturer is simple. You cannot patent baking soda. You cannot create a subscription revenue model around a box of baking soda and a dollar tube of cyanoacrylate. So the industry quietly let this knowledge stay buried in trade circles, while it built an entire ecosystem of proprietary repair products, authorized service centers, and replacement part pricing structures designed to extract maximum money from the moment your plastic breaks. Before I walk you through the exact step-by-step process, I need to say something directly. This is one of several dozen techniques, formulas, and documented methods that we have compiled into what we call the Complete Buried Blueprint Vault. The link is in the description below this video. Inside that vault, you will find guides covering everything from hidden water damage remediation methods used by professional restorers to energy efficiency modifications that utility companies have lobbied against, including in consumer information, to structural repair techniques for wood, concrete, and metal that the contractor industry has zero interest in the general public knowing about. Everything in there is real. Everything in there is documented. And everything in there is the kind of information that saves people thousands of dollars the moment they need it. Check the link in the description. But stay right here, because the way you apply this specific technique is everything, and getting it wrong will waste your materials and leave you with a weak joint. Now, a critical safety note before we go into the how-to, because I want you to trust this channel, and that means I am going to tell you the things that other videos gloss over. The exothermic reaction we are talking about is real and it is fast. When the cyanoacrylate hits the baking soda, the joint will get noticeably warm, sometimes hot enough to cause discomfort if it is directly against your skin. Do not hold the pieces together with your bare fingertips while you apply the baking soda. Use clamps, use tape to hold the alignment, or press from the sides rather than directly over the joint. Cyanoacrylate also bonds skin instantly and completely. If you get it on your fingers and press them together, treat it as a serious situation. Do not try to pull them apart with force. Use acetone, which is standard nail polish remover, to dissolve the bond carefully. Work in a ventilated space. The fumes from the reaction are not toxic in a brief open-air repair, but sustained inhalation in a closed room is unpleasant and unnecessary. Use thin, liquid superglue, not gel formulas. Gel superglue does not penetrate the surface the same way and will not react with the baking soda as effectively. You want the runny, water-thin, liquid cyanoacrylate. It is usually the cheapest version on the shelf, and it is the one that works best for this. Now, the exact process. Step 1. Prepare your surfaces. This is the single most important step and the one most people skip. Any oil, any dust, any old glue residue, or any grease on the brake surface will prevent the cyanoacrylate from forming a proper bond with the plastic. Use a cotton swab dipped in isopropyl alcohol, at least 70% concentration, and wipe both broken surfaces thoroughly. Let them dry completely. We are talking 30 seconds of air drying, not hours. Just make sure the alcohol has fully evaporated before you proceed. If the brake surfaces are smooth and shiny, which some injection molded plastics are, lightly roughen them with fine grit sandpaper, around 200 grit, before you clean them. This gives the polymer matrix more surface area to grip. Step 2. Test your fit. Before you apply any glue, hold the two broken pieces together and confirm they align properly. Make sure you know exactly how they are going to sit before the reaction starts, because once you trigger it, you have approximately 2 to 3 seconds of adjustment window before the joint is locked permanently. If the break involved multiple small fragments, plan your sequence. Do the foundational joint first, let it cure, then add the satellite pieces. Step 3. Apply the glue sparingly. Place one thin drop, and I mean thin, of liquid cyanoacrylate along the break line of one of the two surfaces. You do not need more than one drop for a joint that is 2 to 3 inches long. Flooding the joint with glue does not make it stronger, it makes it weaker, because excess glue that is not in contact with the baking soda or the surface will remain liquid inside the joint, creating a weak pocket. Less is significantly more here. Step 4. Join the surfaces and apply the baking soda. Press the two surfaces together with the alignment you confirmed in Step 2. Then, immediately, with the joint still pressed, sprinkle a small pinch of standard baking soda directly onto the joint line. You will see and possibly feel the reaction start within 1 second. Hold the pieces steady for 3 to 5 seconds. The joint is now cured. Do not try to test it by pulling it apart for at least another 30 seconds while the deeper cure completes at room temperature. Step 5. Remove excess powder. Blow or brush off any loose baking soda from the surface. The white residue that has hardened into the glue line can be sanded flush with any fine sandpaper and then painted or finished to be completely invisible. Step 6. And this is where this technique becomes truly extraordinary. If you are not just repairing a clean brake, but actually rebuilding a missing piece, a snapped tab, a worn gear tooth, a crumbled bracket, you can build structure from nothing using layers. Apply a drop of glue to the area where material is missing. Sprinkle baking soda over it. It cures instantly into a small bump of hard acrylic. Apply another drop of glue directly onto that cured layer. Sprinkle baking soda again, another layer of hard acrylic. You can repeat this process as many times as needed, building up a solid mass of structural acrylic cement that you can then carve, file, sand, drill, and tap with a thread just like you would a piece of hard plastic or aluminum. You are not just repairing a broken piece. You are manufacturing a new one, in place, for the cost of materials that are already sitting in your kitchen and your junk drawer. So let's put this in the terms that matter most. You have a $300 vacuum cleaner sitting in the trash because a 1-inch plastic latch broke. A replacement latch, if the manufacturer even offers it separately, which most do not, runs between $30 and $80 plus shipping, plus waiting a week. An authorized repair technician will charge you a minimum diagnostic fee just to look at it, often between $60 and $90, before the actual repair cost. And if they determine the entire assembly needs replacing, you are looking at $150 or more, which is half the cost of the machine, which is exactly the calculation they want you to make, so you throw it away and buy a new one, or you spend $2. $1 for a tube of liquid superglue at the hardware store, which you will use for the next 2 years on dozens of other repairs. And a box of baking soda that costs $1 that you already own that will last you effectively forever, and in 60 seconds, your machine is fixed, not patched, not temporarily held together, structurally repaired with a bond that will outlast the rest of the plastic around it. The industry prays every single day that you never make that connection. They have built $500 billion in annual revenue on the assumption that you will believe a broken piece of plastic means a dead machine. That assumption is now gone from your thinking forever. Subscribe to this channel right now if you are not already. Share this video with anyone you know who has thrown something away because of a broken plastic piece, because I guarantee you know someone who lost something they valued to this exact trap. And leave a comment below telling me what you are going to repair first. The response section of this channel is one of the most useful places on the internet for this kind of knowledge, because the people watching this are exactly the kind of people who have figured out other things the industry does not want shared. The next blueprint opens soon, and what is inside is even heavier.